Hi. So welcome everyone for the Codebase Jigsaw workshop. It's basically what's called the typical codebase structure, and also it determines how it all fits together. Okay, so let's start. So introductions. Some outline that we have. We have the introduction about the importance of the codebase structure. We have the typical codebase for a frontend and the typical codebase for the backend. So I'm just gonna point out that this presentation is intended to be a brief overview about the typical code-based structure. If you want more information about anything mentioned, feel free to reach out with the project helpers and also to the CFC committee. Okay, the next one, introductions. So most code base will follow almost the same pattern. So if they change, it will actually only change like in the little quirks. And you're going to see that in the next few slides with examples. So the importance of structure is that it helps every software engineer understand the code base and where to put certain codes. So in the previous workshop with the practical software engineering practices, you might have seen that we have the utilities folder, which contains the operations. We have the test folder, test file and test folder that contains everything about the test. So having this structure makes it easier to convey meaning into what particular files are all about. So as you've seen there, I might have only said create test for the description, and it's your decision where to put it. So ideally, you're going to put it somewhere where it's easily understandable. And when people talk about code readability, it's not just about what your variable names looks like. It's not just about how efficient your code looks like, and also uh, certain for loops and things. It's also about the structure of the entire code base. So did you use the correct convention? Did you use the same pattern? Things like those. And code conventions are usually agreed upon by the team. It's not something that is set upon by just some standards. It's something that is set by the team. So the good thing about that one is that if you have better code readability, then you have better collaboration with the team, and also better profit. Stunks. Next one, front end. So front end will typically have a couple of things. So let's move on to the next slide. Front end will have a couple of things. You have the components. You have pages or views, routes. These are different names of it. You have assets, or also known as the public, utilities, helpers, constants, and tests. So in this particular workshop, we're going to be taking a look at the repository for the code base of the website for the Coders for Causes. So let's go. So this is what the website looks like. You have the header, you have some form of description, and also this is also a component if you think about it. You have the community section, you have your clients, sponsored and partner clubs, and also you have your footer. So let's take a look at that and what it looks like in code. So components. So components are the individual parts or pieces of a user interface. So this is what the GitHub repository looks like. If you go to the website and you go to the folder components, you have certain different things. You have the about section, the auth section, brand, dashboard elements, and so on. And if you go to the about folder, we're going to see a couple of things. You have the about page section, you have the committee section, the map, partners, special things, and sponsor. I think in some extent you're going to be able to look at the fact that every single folder is here corresponds to the about page in some extent. Committee, you have the map, you have your partners, special thanks, and also you have your sponsors. And if you go to a specific section, the about page, and the about page has a couple of things. You have your index DSX file. It contains the source code for the actual about page, and then you have your stylings. So by just quickly looking at this one, because of how Jeremiah structured the code base, you're going to expect that every single folder out here is going to have two files. It's going to have an index.tsx file, and you're going to have a styles.tsx file. And I'm pretty sure that's almost understandable for anyone that's going to go there. So let's go dig deeper. That's There's another folder called pages. And pages are the direct components that are related to a specific to a route or URL. So as you might have seen right here, this example, we have this entire page, which technically is also a component, and that page alone contains more components. So let's take a look at what the code looks like. So this is what a convention looks like. So you have the about, you have the metadata for the thing that goes at the top of the page, and you have your about page component. Your about page component, if you take a look at this thing, goes from components to about and then about page. If it's going to load more, it's going to be components and also some other files. Okay, now let's continue with this deeper. So it's pages, right? Let's go back to the component section of about. And if we take a look at it, this is the about page. Let's dig deeper. This is the about page index.tsx file with all of its reference. So let's just cut around here. So you're going to see that these are all library imports. And at the bottom here, you're going to see that these are all project repository imports. And take a look at this directly. This is the about page section, the index.tsx file. It's going to have reference for files or folders that are within this about section. So about page has components of different things, committee, clients, partners, sponsors, at this exact section. So that's one way you could see that because of the way how it's structured, it's easily understandable. Next one is component reuse. Of course, there are pages that have direct components, such as, for example, this one, wherein the about page has the committee, the map, partner, a section. But you might have different components that are not actually related to a specific route. So you're going to have what's called a component reuse, wherein if you take a look at the utilities folder, you're going to have a couple of things there. You have the add-ons, you have clients, footers, header. If you think about it, footers and headers are not specific to a page. It's basically something that you would include for a group of different pages. You might even include it for all the pages. Okay, moving on. We have the assets or the public. So assets are usually elements of a code base that have references maybe to images or video files. So something that cannot be really represented with code usually. So you have, if you take a look at it, website, you have the public folder, and then you're going to have more different folders here, but all of them will just contain either images, videos, or some other assets. Next ones are the utilities or the helper functions. Okay, just to clarify, is that the utilities or helper functions are not specific to the front end. You're going to see it later on in the back end as well. So these are pieces of code that are used as utilities or helpers to other codes. So let me give you here an example. You have what's called the utility components, something that is not specific to a particular page. You also have what's called the utility functions. So an example with that be is the global, and I think what global holds is the constants that are used in the code base. But you might have different functions that are not specific to something. Let's say, for example, if we take a look at how a website works, is that they might have a convention that if a particular page has, for example, spaces around it. So let me just think of sign in. You're going to usually see that there's going to be a dash that comes in there. So I think you're going to have a function that converts a particular string to something that looks like that, with spaces converted to dash. And you might ask, if that particular function is being used almost a lot of places, different pages, different components, then you might want to put that in what's called the helper function sections. Okay, and um, also important is automated testings. So where do we put the tests? Well, firstly, what are tests? There are scripts that test that code works. And for front end, it's usually an end-to-end kind of testing. And I'm not going to cover end-to-end testing here, but there's a couple of examples. You have Cypress. The short summary of Cypress is that it's kind of like a human performing actions like click, keyboard typing, but it's summarized in an automated fashion such that a code will run those kind of actions. So this is what it usually looks like. You have a folder called Cypress or integration test or test that will contain more files about the test. There's also another way that you could do this. In JavaScript at least, there's a convention wherein you put .spec.js and you put the test inside the same place as you would for all the other files that you had. So for example, you had a function for authentication, and you're going to put the testing file, at the same place as it is with spec.js. Okay. Now, you might be asking, we've only taken a look at one code base here. We've taken a look at the code base for the website of Coders for Causes. But how does this translate to other code base? Well, as I've said, there's only going to be a slight difference. And let's take a look at this, for example, the WAIS front end. We've said the public will contain a couple of assets. We have the tests that are written there. And also, let's take a look at the source folder further. You're going to have views and routers. Those are similar to like pages because they correspond to a specific URL. You're going to have the component section. And again, you're going to have assets. I'm not going to be able to answer to you why there's a different folder for the public and also the assets. But code base will slightly differ. And to only know what the couple of the difference would that be is that you look at the software documentation for that particular project, or you ask the other engineers that are working that project. Okay, I think that's clear. Any questions before we move on to the backend? Okay, I think there's no question, but if you have some questions, just feel free to ask me at any point. Next, let's move on to the backend. So, contrary to popular belief, people think that this is what the front end looks like and also the back end. Functionally working, that's actually how it is. But in terms of the structure, it's usually like this, if you think about it, because it's usually not opinionated. So let's go into take a look at here. This is the example that we're going to take a look at. An example for Django REST framework project. So I think it's a to-do app. And it's going to follow what's called a subject-oriented file structure. So the backend usually has a couple of things. You have the models, routing, views, and tests. We're going to take a look at that in a second. So let's take a look at this. Okay, this is the code base that we're looking at. It's a to-do app. The to-do app has a couple of folders, the to-dos, the users, and the configuration for the to-do app. Okay, this is what a subject-oriented file structure looks like. So as you can see, this one is a folder for to-do. This one is a folder for users. So it's both different folders, but it has the same file names based on the role of that particular file. Let's take a look at this. You have models.py and to-do. You have models.py and users. You have tests, URLs, and also views.py. I've highlighted the most important files right there. But as you can already see is that folders that are different, depending on what their subject is, has the same files for the same role. Another way you could take a look at this is what's called a role-oriented file structure. So you might have seen previously, you have a folder that is specific to a subject. Now, we have a structure wherein a folder is specific to a role. So you're going to have model here, that contains all the other models. You're going to have services that contains all other services. And this is what it looks like. You have models, services. It's going to be specific to a subject. Different file names for the subject. Events, groups, notifications, and notify templates. And this is backend as well. Role oriented. Okay, let's take a look at models or ORMs. So ORMs are what's called Object-Relational Model. It links the database into your apps into objects. So in the case for WAIS, we're using PostgreSQL. But if you take a look at the documentation further, is that you're not doing raw SQL logic. You're going to be using what's called an ORM, wherein it kind of feels like an object. I'm going to say, hey, get this, and then I want this particular property. And this is what the ORM looks like. You have a mapping logic, you have your objects, and also you have your database. And let's take a look at this in two examples. This is what the model looks like. You're going to be defining a particular class extending from a model, and you're going to have particular attributes there that basically defines its schema. Is it foreign key? Is it a character field? Is it a Boolean field or a datetime field? Let's take a look at this for example as well. You have your notifications. You have a notify for a specific user. It was sent on a particular date, send on a particular date, and sent on a particular, actually sent as in whether it's true or false. Yep. Next one is routing. So routing determines the rule for the URL patterns for your application. So in the case for the to-do app, it's going to have a couple of things. You're going to be listing all the to-dos out there, or you might want to take a look at a specific one, like a particular detail, or you want to do a update, delete for a particular primary key. Going back to another code base, you have this one. It declares the pattern for that particular service or view, as one may say. Okay, next one is view. So in REST APIs, views are your main view of the API. So in an essence, I think earlier in another workshop, we said user interface is where user interacts to the application. Now, application programming interface, you have your application program interacting with a particular interface. So this interface will be where your application will interact with. So for example, list create app API view, what it's going to do is that it's going to do a filter for a particular user for all it's to do. And then a couple of detailed ones, you can do update, destroy, or update or remove. Here on the other hand as well is that you have this thing. I know it's a little bit misleading because this takes advantage of what's called object-oriented programming, which it does with inheritance. So course evaluation extends service. Basically, it inherits everything that is on the properties of service. And the properties of service can be summarized similar to this one, which is you have the get, post, put, patch, and delete. So this one, if you connect a particular service with a model, it's going to create all the REST API endpoints for you. So this is a bit misleading, but just to make sure that technically this one does inheritance as well to a certain degree. If we're going to write that in, let's say, for example, Express, wherein it doesn't abstract a lot of things that happens, be mindful that you're going to have to program each individual request method: get, post, put, patch, delete. Next one is testing. Okay, testing are usually the most common candidate for transitioning from file to a folder, because later on you're going to have your tests that will extend such that it's going to have a lot of scenarios. Take a look at this to-do app test, for example. It's already very long compared to what we've compared before. That's the reason why I'm saying that the test.py over here later on will become a folder called test, and then it will have more files in the test folder. Okay, I guess that these are the useful resources for learning about file structure. Let's get on with the demo. Let's do actually, I don't think there's a demo for this particular workshop. There's actually a demo for the next one. Any questions? Looks like I might have underestimated the time that this workshop takes. I thought it was like 1 hour. But turns out it's only 20 minutes. Is there any question, guys? Yeah, absolutely anything. In your food bank project, in your view waste project. All good, guys? Okay, because I think we're right ahead on our schedule. Let's just take a look at a couple of code base right here. So this is what I was showing with the code base for the website. You have your components, and then page, the about page, will contain really two things. And if we take a look at other files as well, it will contain some folders, but it will usually contain only one bit. Index, tsx, and styles. And that's where the importance of the file structure comes in, is where you make a particular project, even though it's growing really big, because of the way the consistency works, you can predict certain elements or properties of the project. So going back to this one, the about page, the about will have the same folder as the about folder section, and in the about folder it's going to have a prefix or suffix called page, and all these other components right here are reference to these things here. And let's actually just take a look at that in another folders. Let's take a look at brand, for example. Yeah, brand page. Brand page will have references towards the color card and the logo card. And if we take a look at page as well, it's going to have a folder called branding, file called branding. But almost similar. Yep. Okay, I'm going to stop the recording here.